All right, good afternoon, everyone. I have the same challenge that Simon did of not actually knowing what time it is. And I'm in the time zone where I live, so I'm sure many of the rest of you are much more dazed and appreciate everyone joining us here in Pittsburgh. A couple of things that Bill said, spot on. If you are asked to moderate at a conference like this, you should also ask who's going to be on the panel and what time in the slot will you be going. I said yes, not knowing that I would have the privilege of sharing the stage with 5 of the smartest people that I think you could put into a single room, and certainly didn't realize I'd be going first. So we're going to try and keep some high energy up here and appreciate everyone's time. The thing that we're not going to do that Bill was wrong about is we're not actually going to spend a lot of time on introductions. I have had a chance to dig into these folks' LinkedIn profiles over the past couple of weeks. I'd encourage you to do the same, but we only have about 50 minutes to have a really critical conversation. And so we're going to jump right in, and you can do your own research as we get to a break later this afternoon. So as Bill said, our focus today is on the intersection of the energy and industrial sectors. And really critical for the Pittsburgh region, and certainly globally, is how we think about that, not just through a fourth industrial revolution context, but also how we can use this collision of industries to drive economic growth, advance globalization, and do that in a platform that continues to drive us towards net zero energy. And we're going to do that in a landscape that also touches on how important data is to framing the collaboration to drive that forward. So with that, Hillary, all the way on my right, stage right, never got the theater directions correct. So Hillary, you're joining us from Shell. Shell has a significant presence and investment here in Western Pennsylvania. I was wondering if you could kick us off just a little bit of what does fourth industrial revolution technology mean to you in your professional life? Is Shell's investment in the ethylene cracker facility an example of that? And if so, why is that important to Shell and to the region?
Yeah, so thank you. And, you know, we're building an ethylene cracker, or built an ethylene cracker here, and polyethylene units. And I think, you know, we've tried to make it a fourth generation or fourth industrial revolution plant. So, you know, I was thinking, what does the fourth industrial revolution really mean? And I think to me, it's around the changes that we see both in technologies, industry, society, in terms of the interconnectivity that we now see and the much greater enhanced automation that we've got. And so if I think about it, you know, it encompasses everything from advanced robotics, through gene editing, through everything and anything, the Internet of Things, and how do we use those to actually take our industry forward. And so if I then pivot to our own plant, and I will say it is Shell's largest investment, capital investment in the world, and it is by far the most digital plant that we have ever built. And if I take an example of that, of how we have used some of these new technologies that become available both in the construction phase, which is historically a very, I would say, old-fashioned sort of industry, and also now as we move into operations. So think, you know, drones. If you've ever passed by our plant at the weekends, you will see masses of drones flying every day at the weekend, taking multiple photographs to help us really understand and augment our digital twin. So we have a complete digital twin of the plant. We can see, for instance, with all of that drone imagery, the difference between what the plant looked like last week, what it looks like today, and really measure our progress, understand where the project is progressing, where it's not progressing. If I take another example, again using drone technology around safety, our ability to fly drones to see unsafe acts or unsafe conditions and actually send that information immediately for interpretation, actually not even in this region, but to, in this case, to India, to get analysis, machine analysis, and then furthered by people actually looking at that analysis to make sure that we're correct, and then being able to correct near term. And then if I move into the operational phase, you know, having a multidimensional dynamic simulator allowed us to train even during COVID. You know, in COVID times, it's not that long ago, March 2020, we had to send everybody home. Now, when you're about to start a plant up, How do you then train all those operators when they're actually remote? Well, actually, with a dynamic simulator, that's no problem. We can actually do that from wherever anybody is in the world. And similarly, we can engage with, for instance, our suppliers, Elliott or Emerson, can actually support us now remotely, giving us access to far, far more technology, far more availability of people to actually make our plant better.
That's great. Great framing, Hillary. And it really boils back down to when we think about the fourth industrial revolution, we're thinking about collision and we're talking about data and information, and how that really underscores, as you said, older technologies, but also the most cutting edge. And here in Pittsburgh, a lot of our conversations are on machine learning, artificial intelligence, augmented reality, and I think that underscores kind of Shell's investment in the region and why, beyond just our natural resources, why that investment is so important on both ends. Allison, I want to move to you. The Shell cracker itself is a physical example of the industrial economy and the energy economy coming together. Your work at Baker Hughes really focused on energy transition. So can you talk a little bit about how fourth industrial revolution technologies can help us to diversify the energy mix without losing that industrial capacity, and how that might affect industrialization moving forward?
So this is actually the first time I've spoken about that nexus, and I speak a lot publicly, but the 4IR piece is really interesting on energy transition, but we first got to agree on what we're talking about, so just indulge me for a second. Historically, the energy transition was a pejorative term meant to drive the phase out of fossil fuels. So there are probably many of you in the room that strikes at the heart of your business. And it doesn't make sense because it actually, if you think about it in those terms, it means that we will have a less dynamic and robust energy mix, which leaves industrials out there hanging because you need a lot of high BTU content. So what we think about today is really, we talk about it in the sense of it being the great carbon transition. And so it's getting the global economy to a low carbon state in line with the Paris Agreement of net zero by 2050. All right, so when you think about it in that aspect, the burden is not just on energy companies like Shell and many of our customers. It's on the global economy. So the World Resources Institute is a nonprofit organization based out of DC, and they put out an outlook periodically on what carbon is doing and how are we doing in the world and what sectors need to work harder. As it turns out, for their 2020 readout, it's industrials that are predicted to be the fastest growing carbon producers in the world, followed closely by power utilities and home heating providers, and the third sits in transportation, as you would expect. So the role of the 4IR piece becomes really critically important because you cannot look at emissions reduction until you have a great real-time monitoring feed and go from modeling your progress on emissions reduction to actually measuring it. And so a lot of what we do at Baker Hughes has the oil field service side that many of you might be familiar with, but the other part is an industrial energy technology company that is heavy in the industrial asset management space, sensors monitoring, edge computing, and using all of the great things that she was talking about in the application first of producing energy smarter and more interconnected, but allowing us to then actually pivot from speculating how much we're producing by the emissions and seeing it into more of a predictive capability down the road. We have a partnership with C3 AI that we've been working on to look at facilities and how you can measure your carbon and your electricity and all of your use, and then start to predict and balance the load off a facility or manufacturing site. So suddenly you can use this as a way to really dynamically control both energy, emissions, and cost. And let us forget that cost drives a lot of the businesses that you see here in the room, is we want to make sure that we have prosperity in mind as we're doing that. And so that nexus is quite tight, and I don't see the world getting to the carbon transition we're talking about if it's not a little bit more connected and we can't monitor our progress today. Because right now, everything we do in the energy transition for measurement shows up as a lagging indicator. So we're always going to be behind unless we embrace this to look forward into the future. And that's what we're working on with a lot of our sensors and condition monitoring that we place in most sectors around the world today.
So talking about sensors and monitoring, And Mark, I know that what Allison's talking about really, as we were coming on stage, really getting to this, we need to be thinking about carbon as the end state. So I want to come back to that, but I want to pick up on how much information is happening and how that relates to data, and I'm going to throw it to Marcelo first and then come back to you. So Marcelo, can you talk a little bit about the role that data will play? A lot of input sources at both the Shell plant and, as Allison was saying, that Baker Hughes is working on. So what's the role that data plays in energy transition, and how can we harness that to solve energy challenges, and are we looking at new standards of data to really capture that much information?
Yes, I think that, like it was mentioned, we are in a transition that we will have to live with molecules and electrons for decades. And in this transition, new technologies that have appeared, like Hillary and Allison mentioned, just to have a dimension, like 10 or 20 years ago, a chemical plant or a refinery or a steel plant will have 10,000 measurements. And nowadays, they will have more than double than that, right? And that's because the technology allows us nowadays to measure things that we were not allowed to measure online in the past. And this brings a lot of data, not only from the operational point of view, but also from other aspects of the plant, like reliability and energy, and of course emissions, like was mentioned. And I think that all these data accumulates, and it requires a data fabric to actually make decision-making. Like it was mentioned, we need to get more leading KPIs. And in this aspect, I think that as an industry, we have to be working not only ourselves, but also with regulatory bodies, with academia, on the data models that will actually help accelerate all this process. Because today, there are several models, like Namur has some of them, SESMI, that is an organism from the DOE also, has some models that we have been working with, but they are all separated. And I give you an example. We did work with a downstream company, refining and chemical, and to be able to look at everything that they look on their monthly report, we have to create a data fabric to take data from more than 150 subsystems. And that's a lot of data that you need to contextualize, and you need to gather all in the same place, as structured and unstructured data. Like Hillary mentioned, nowadays we get a lot of drones, a lot of video data that we also have to analyze, and we have to be able to accommodate all that. And I think that the evolution will be in terms of getting the new data models that we will allow to accelerate these models.
Allison, before we leave this topic, I know you've been putting your quant hat on frequently, as you said, and so to Marcelo's point about this new data fabric, I think you have some unique outlook on how data powers energy transition. I wonder if you could share that as well.
Yeah, so I've really pointed it, we've got a couple of really good examples, but I'll pick one or two and be succinct so we get to hear the views of the panel. We talk a lot about measuring emissions. You can measure almost anything if you really put your mind to it, but what 4IR allows us to do at Baker Hughes in many ways is that we can look upstream in our emissions. And so right now when we talk about net zero, people are still really talking about the operational footprint. We share a joint purpose, Shell and Baker Hughes, so it's good that we're sitting next to each other here. So we're looking for ways of mostly operational emissions out in the world for most companies. But what we're trying to do is look at the entire value chain, okay? And we have to understand from the point at which we have the front end of the supply chain through when we sell a product to the end of its life. And so we look at many phases of how we can quantify emissions, but the real nexus point that you get is that we are both an upstream for somebody else, but then we also produce a product that is directly responsible for enabling either emissions reduction or creating a lot of emissions. And so where we're at today is we look at a whole system. For instance, we sell turbines, big industrial turbines. Those turbines have a pretty sizable scope 1 and 2 emission when we sell them to Shell, okay? And when that happens, we've got to now think about what does the ecosystem around it look like so that turbines last for decades. You've got to build a system that allows you to directly abate emissions from that, and that's carbon capture and storage is one kind. You can fuel shift to hydrogen. Either way, you have to continuously monitor that turbine. We know what it should do in the field. We can compare it analytically over time in its performance so that we're building it to a different kind of design. And then, where it gets very interesting is, the solution for abatement is the entire CCS ecosystem. So that means you've got to use everything that we're talking about from the point of capture, even before it in the combustion side, as you have a flue gas or anything, whatever it is you're burning, through the entire value chain until you put the CO2 molecule in the ground, just like what he was saying with measurement of molecules. And so this big data piece is gigantic for one product, right? If you sold a turbine, and then there's a whole ecosystem around it. So that's how we're approaching it, is looking at the full ecosystem as one solution versus a product that you measure something off of.
And just to add to that, I think it's incredibly important that as a world, as a population, are interested in transparency and really being able to follow that molecule.
Exactly.
And really understand that, yes, it really is being abated. And that we're not involved in greenwashing or whatever. Without the data trail and being able to demonstrate to people that we're really doing what we're saying, this will never succeed.
Go ahead, Mark.
I was going to say, you pointed out exactly what fourth industrial revolution technologies to date really have focused on the scope 1, scope 2 emissions. Scope 3 emissions are where the carbon is.
It's where it's at.
Yeah.
It's where it's at. If we're trying to get at the carbon, I'll give you a great example here. Auto industry. Everyone's familiar with the auto industry. For the auto company, the number one scope 1 emission for them making that car is literally drying the paint on the car. There's not that much energy used in the auto factory. Most of the carbon emissions come from one of two sources. Either the coke going into the blast furnace that makes the steel in the first place, or up in the basic chemicals, both of which are commodities that have very cost sensitivity to them, and they're about 7 layers deep in a supply chain. And there is absolutely no visibility to that end-use car that, hey, we're actually getting our ethylene from a plant that actually has a lower CO2 footprint. They're just averaging and saying, oh, this is how much CO2 it takes. To the point where we can actually start sharing that data between firms and across supply chains. And these are international supply chains. It's going to take international standards to wind up doing this. Till we get to that point, you're not going to be able to charge a price premium by saying, hey, we have the lowest CO2 emitting ethylene. But at that point, suddenly you then have economic forces that wind up driving into that point. So one thing I'm really interested in are things, and I know UNIDO, the co-sponsor here, is a big part of working on things like ISO 50001, which are global standards, and ISO 14000 that work towards carbon and carbon accountability the same way ISO 9000 works on quality. And at the point where you wind up having that get into supply agreements, that if you're going to be a supplier to our car company, you need to have ISO 50001. And if you're a supplier to your supplier, they need it. Then you wind up having that propagating throughout the economy. That suddenly just becomes a much more rich data science problem to wind up solving, and how we wind up sharing that information.
So, Mark, you're underscoring kind of it's going to take multiple industrial and energy sector collaborations to make this happen. So while you have the proverbial mic, I'm wondering if you can talk a little bit more about how those sectors should collaborate. And I know you have a South Carolina model, and maybe can use that as a framework.
Well, I think this is looking at how the fourth industrial revolution. My day job is, I work with the Department of Energy my title is actually expert advisor, which I love as a title, by the way, on industrial programs. But my day job is I actually am a faculty member at Clemson University down there. And looking at the fourth industrial revolution and where it's adopted in the manufacturing sector in the United States, I would argue that that's one of the places it is in the country, mainly because the GDP exports per capita for non-fossil fuel exports, for things that aren't just taking oil out of the ground and putting it in a tanker and shipping it, but are things you're making, are higher per capita in South Carolina than any other state in the union. So what are they doing well? And there are kind of three things. One is focus on really, really good logistics. You don't have minimum friction between the product coming out of a factory and getting to their customer, or from your supplier to you, you're not going to be able to integrate these things well. You can have all the data in the world, but you need to have that seamless logistics, whether it's port, whether it's air, whether it's rail, you name it. And so having that investment matters. Second thing is actually education. Pat, I'm certain will wind up reinforcing the education as the University of Pittsburgh does great work on this. I'm not talking about the PhD production education. I'm talking about 2-year colleges. There is literally nothing that replicates the 2-year college system in the United States in any other nation in the world. And that's who's educating the workforce that are actually the rank and file workforce on the floor of every manufacturing facility. That's actually the secret sauce for innovation in the United States. So how do we take what we're doing in our PhD level, how we're developing virtual reality models of simulations, and making it so you can deliver educational content to your workforce in new ways, huge impacts can happen from that. Then the third thing, and Pittsburgh's a great example of this, is essentially state and local leadership that has a vision and puts resources behind it for how they wind up changing. It's amazing what's happened here in Pittsburgh, that in 30 years, it's actually changed its vision of what it is as a city in a way that other cities haven't been able to do that. You go further down the Ohio River, you'll find cities that are still waiting for that steel mill to come back that went away 30 years ago. If you come down to Greenville, South Carolina, 30 years ago, it was viewed as the textile capital of the world. That industry's gone away. They've re-envisioned themselves as being the leading exporter of automobiles in the nation as a result of it. So having those local governance structures also really matters for making those transitions. Sorry, I just went way far afield for data science on this, but those 3 things are things that the scientists will tell you, oh, we need better, computational models or supercomputers or whatever it is that's there. But getting the people together, getting the leadership together, and making it so it can be interacting on a global basis, that's what gives you competitive advantage.
Mark, you zoomed us out exactly where I wanted to go. And Hillary, I'm going to come back to you because Pat got name checked. And so I want to pass it to him, both, Pat, for a response on this model of logistics, the community colleges, we would say in Western Pennsylvania, the tech school, as we would say in South Carolina, and you are both the local leadership and the academic leadership. You wear both hats. Selfishly, Mark, I would add advanced research into that, which is why one of the reasons the University of Pittsburgh has pushed the industrial capacity of Western Pennsylvania forward. So Pat, pick one of those 4 verticals, add a new vertical. Tell us what is the importance of the university ecosystem in driving this transition?
Well, it's kind of, at first blush, it might surprise people that universities play a central role, but they often have played catalytic roles. And as you listen to this discussion about this transition or transformation, it's really driven by reintegrating what has become a segmented system, right? So we segregated energy from manufacturing because it was very efficient. We commodified energy outputs, and we've done that with supply chains. And now we're suddenly attaching value to the properties of the products and not just the products themselves. And that requires a reintegration in a very deep way. Part of that is technical. And so this whole interoperability, supplier, supply chain integration, deep data, smart systems, 4IR, that's certainly a big part of this. And some of that does not need proximity. We just watched the Congress pass the CHIPS Act. That's an industry sector that has allowed such high levels of interoperability that the chip manufacturers that produce the chips are fabless designs. They don't have factories in these global fabrication facilities. And I think there's some elements of that here that will be technology-driven business and deep interoperability. But particularly when it's nascent, I think that there is a type of interaction, and Mark was really touching on this, that's driven by the shoulder rubbing, high proximity. And I think it involves several things. One is knowledge, and the knowledge comes in 2 forms. So certainly R&D activity is a major driver in any innovation-intensive area. The universities play a unique role in the R&D system in that they really tend to function predominantly in the fundamental research. That means pre-application, so that might be a liability for some of the applied work, but it also means that it's pre-competitive. And so they very often lubricate the interaction between competitors on R&D questions because they're naturally operating at this pre-competitive stage. So a lot of times you'll see, much like you did in South Carolina, collaborations of industries anchored by research-intensive university, and so that research role becomes very important. Something we're seeing in Pittsburgh as well. The other one that Mark touched on is knowledge in the form of skills, and it's all through the employment sector, from highly technical R&D all the way to what are now quite technology-intensive line positions that support these technology-enhanced roles in companies and in the energy sector. And it's changing fast. So an interesting skill issue coming up, which is how do you constantly retool a workforce when the dynamism of what they're doing is changing faster than the length of a career. And so we're looking at fusions of educational suppliers and companies and this sort of continuous learning models and stackable certifications and all the things that are being talked about now. And the last role that universities play is the one that, in my view, sometimes is the most important, but it's also the most indirect. We talk about collaboration and partnerships, but it's really about mutual exploitation. That's really what makes a great partnership work, is both sides are getting something from this in a competitive context where you're looking for win-wins. For that to happen, you need a Switzerland. You need a neutral party that can be the convener and catalyst. And universities are often that role, and for two reasons. One is because they're structured to be outside of the competitive lanes, but they're also regional entities. They have campuses that are in a place, in a location with a very high concentration of skills, knowledge, and assets. And so we often get leveraged as conveners, particularly in the early stages. So a lot of the discussion happening now on energy hubs or carbon efforts around hubs and clusters. Universities are often playing central roles in bringing together these various parties and setting kind of the framework for collaboration so that it can unfold.
And that's particularly poignant given how much money is at the federal government right now looking for regional partnerships with which to deploy it. University of Pittsburgh, along with our hosts here at the Allegheny Conference, really central in Pittsburgh winning a $60+ million Build Back Better award. I know the University of Pittsburgh, Penn State, West Virginia are all lead applicants in the National Science Foundation. We have CHIPS Act coming up, so it really takes that new economic development role playing Switzerland to keep our, especially industrial regions, I think.
Of course, we would never do it just for the money,
Absolutely not.
No, I'm being a little bit facetious, but it is important to note that these new federal programs are, yes, they're producing a lot, providing a lot of funding, but they want to fund the cluster. They want to fund the hub. So the interesting chicken and egg problem is how do you form and produce a critical mass of collaboration that is fundable? And that really is the central role of the universities, is to leverage their structure, their place, and their talent, and use that as a kind of an incubation, if you will, to create that sort of collaboration at scale that can then receive the funding and drive further. So,
Hillary, go ahead.
I'm just going to add to that. I mean, to move through the energy transition is going to take, it's going to take everybody, actually, and it's going to take almost every technology we have. It's probably the biggest challenge, I think, that man conceivably has ever, or woman, has ever faced. But just a couple of other points as well around education. I mean, many of you will know that we set up a process technology course at the Community College of Beaver County. So to your point, the 2-year courses, and why is that important? It's important because actually the people who really drive change, or in my view, who really drive change, actually are the people who probably are a lot younger than the people on this stage. If you look at the speed of change through this fourth industrial revolution, the people who adapt best to the speed of change that is required are basically the younger people. The people who embrace new technologies, who look for those. Just think about what's happened with Facebook and Twitter and the emergence of all of those things. It's driven largely from the young. And the day that I really look forward to is the day that one of those graduates from the community college comes into my office and says, come on, where are my Google goggles? Where's my dynamic simulator? Where are all these tools that you're telling me about that can make this transition happen, and demanding them of me as an employer? Because I think that's when you will see actually also that acceleration of change.
I'm incredibly optimistic about the next generation from this perspective, particularly the community of gamers. Just to give you an example,
absolutely.
I will not say the auto company here, but let's start out with computational design tools that we all work with, and everyone's got their unique process. By far and away, the biggest, most widely used computational design tool in the world in terms of number of users is Minecraft, followed closely by Roblox, which are physics-based models, and you talk to your grandkids about them. They're what they're playing with in their games, and they're designing entire worlds inside of this. You say, well, that's just a game. No, they're actually physics-based modeling. That's all the difference in the world. So there was a auto worker at an auto company, I won't say which one, that was literally on the assembly line. But he's a gamer, and he decided, I'm going to just build a Minecraft model of where I work. And then he built one of, it's an assembly line. It's like, what's the next station? What's the next station? Just laying out where things would be to try and figure it out. And he showed it to his bosses. His boss was like, you realize you just built a digital twin of our auto factory. Like, we pay consultants a lot of money to do this. He's like, oh, this just...
And gaming technology, in the sense that you, in this day and age, you can provide an operator with a view of the best that the plant can be in real time. So, optimizing the plant in real time and actually giving that person on the panel almost like a target, much as in gaming technology. And that's available, and it's available today. And actually the younger generation, they embrace this. They don't see it as a test or a challenge. They see it as just fun and part of actually making the world better or more profit or whatever it is. So there's something in there. But I think the other piece is around the collaboration, and again, the extent of change that the world is going through, whether it's in the digital space, in the energy transition space, is at a rate of change that we have never seen before. And in doing that, it's important that we take all parts of society with us. And to Pat's point about the universities, I think they play a pivotal role in being that advocate who is neutral, who can advocate for these technologies as opposed to companies perhaps who have a vested interest in what's going forward. And certainly the hydrogen hub technology, or the hydrogen hubs that we're now looking to partner, we're partnering with Equinor and other companies to actually apply for that funding to actually bring a hydrogen hub to this region. We can't do that without acceptance by the general public, and also leveraging the technologies that sit in all sorts of different companies. And the universities give us access to that, and I think give us a credibility and a trust that on our own we couldn't actually provide.
So if you have your fourth industrial revolution bingo card in the audience, we've hit hydrogen, digital twin, a couple other words, education, and that means it's time to talk about policy. And then I'm gonna come back. But Marcelo, I'm gonna ask you and Pat, and then actually Mark and everyone I think probably has interesting views on this. What policies and enabling mechanisms are we gonna need to encourage or force maybe collaboration between the industrial and energy sectors to really accelerate the goals that we're talking about? Marcelo, you wanna go first?
Yes, I think that a really great point that Mark made is the new generations are looking at this differently, right? And bring us a lot of new qualities that will help accelerate this transition. Now, when you look at our regulatory bodies, they are looking still, many of our regulations are looking still at technology that is many, many years old. And I give you an example. One of the emissions monitoring acts that we have at the EPA is using technologies that is 30 years old. And there are many new technologies nowadays that allow us to be much more efficient monitoring those emissions, but it takes many, many years to actually adopt those technologies by these bodies. The same Mark mentioned before, the ISO 50001 and the 45,000. And I think that that's a great alternative, that's a great body, because one of the things that we as Emerson have, and I think that everybody here in the audience, is that we need to track the different carbon profiles of every component in our products, right? And we need to identify those for where the source is coming from. And today there are a lot of databases, everybody uses the same, and these are going by countries. But we need to get a granularity that we start identifying the places that these different things are produced, foundations or plastics or different things. And when we start doing this, what is the end of life of these different materials, right? How we are going to recover the rare minerals from batteries, how we are taking post-consumer plastic and converting that into new polymers, right? And because we cross borders, we need to have these international standards to help us get there. But also, if any of you work on any of these bodies, it takes many, many years to get there. And I think that the new generations are helping us and pushing us to accelerate this, right? And driving, like what Hillary mentioned, and Mark as well. We need to figure out a way that we are going to live with this and accommodate that. Because I think that from the policy standpoint and the government institution point of view, we are still lagging. We need to find a way that we are really going to accelerate our processes to be able to accommodate these and be much more efficient.
Can I expand
go
on
ahead,
that for a sec? He said something that's important. It's sort of the speed at which policy moves. A lot of the sort of greenhouse gas regulatory premise the SEC is building on today. So I know at least at this end of the panel, we care a lot about what the SEC is going to mandate here in the next month. And within that, it leverages a financial policy, okay? So it brings up something that is literally a voluntary standard that's written by a host of academic people who have not had to do what we are doing using 4IR and other capabilities to actually convert from modeling to measured. So the policy framework that sits around the governance of the molecule and the electron is really critically important to get right. And it needs to be maximally transparent. And that is not actually being done in the government. That's being done by a group called the Greenhouse Gas Protocol, which is a volunteer group, okay? Same thing with Carbon Disclosure Project, also a nonprofit. Same with science-based targets. Like you pick up the theme, all of these groups are not-for-profit policy-making groups and standard setting, just like ISO, right? Well, they might actually be on the edge of profitable, I don't know. But it's policy that we can't necessarily count on electing officials to go in and change for us. So that's the power of collaboration with a group like this, is that we can get together and say, what can we agree to, and then go in and make a case for a changing.
And that gets again back to Pat's point about the Switzerland roles that universities can play within those voluntary frameworks. And Chancellor, to Marcelo's point on circular economy, that's somewhere where Pitt is leading in partnership with Covestro right now, getting out ahead of the policy framework. You've also been on the federal side of kind of how policy is driving this. How do you think we use the policy levers or not to push some of these mandates forward?
Yeah, it's funny. I find myself thinking about my NIST role a little bit more than the university role in this context. When you're in an emergent area like this, I think the most important thing that can be done to essentially de-risk the situation for the pioneers, because that's really the issue here. You don't want to penalize your first movers. And I think there's two things here. One is that the government will be completely mismatched for this, because the formal policy structure, the regulatory agencies are set up to manage the as-is or as-was state. a segregated commodity-based energy sector. We have segmented regulatory authorities. You're talking about an integration problem. It's apparent immediately that there's a structural problem. And the question is, how do you avoid that system basically becoming the immediate impediment? Whether it's infrastructure, new pipeline infrastructure, new knowledge, data sharing across, commercial sectors, antitrust issues, all these things are going to come up. It seems to me that one of the policy things should be, and the tension, of course, is going to be not wanting to deregulate everything forever, because that will raise another specter. So the question is negotiating an appropriate level of deregulation or regulatory flexibility to move into these new areas. And generally, you can look at it as a time-bound approach, where there's some window in time where this happens, or in a place-based approach. And then again, this is where these regional hubs can get quite interesting if they're accompanied by regional sort of, green lighting of various, exploratory models for both regulation, infrastructure approval, things of that type. That strikes me as being very important. I'm not exactly sure how that will unfold in the federal side, because, as I said, you're kind of immediately segmented in terms of how you have that discussion. The other one that I want to touch on is validation. So, in the end, this is going to work if you can monetize the attributes of what you're doing. And so this danger of greenwashing is very real. If you're moving and analyzing carbon content, emission, and you need to have the assurance that your assertions of the property of what you're selling in market are going to be validated by the market. And that's almost like a currency regulation or any other kind of monitored, standard assurance. So, and I don't believe we have anything at market scale that can provide that kind of assurance. And I think that has to happen fairly quickly, at least in particular areas where the market won't function.
Yeah.
It is happening in the private sector, but it's going to really explode in the next couple of years, the moment you get the forcing mechanism from like the SEC and other regulatory bodies.
That's the big thing that's happening right now as policy, is the SEC coming in and saying, you're going to make claims about this, you have to have
assurance.
Assurance
Yes.
about the same way you do an accounting claim. Or
Yeah, but we have to have the blockchain technology that's going to allow that to force through. But I mean, at the simplest answer to your question, in my view, is we need targets, we need incentives, we need education, and we need regulation, or regulation that permits it. Because, I often think, we would like to sequestrate carbon. The carbon atom doesn't really understand whether it's in Pennsylvania, whether it's in Ohio, whether it's in West Virginia. And the regulation in each of those three states is different or present or not present. And so as we move forward, we need to have a more regional approach to ensuring that we can develop across the boundaries, because these are historic boundaries which are not necessarily respected by the businesses we operate or the molecules that we make money out of. So, but without those three things, because let's face it, as we all run businesses, and what do? We set targets for our businesses. We incentivize people to work on particular things. Yeah. We measure, and we put rules around it. What's the difference?
Hillary, that's such an interesting context, going back to Pat's point about the importance of regionalism. And it's a big difference, I think, that it will come up for many of you in the audience and those of us participating over the next couple of days. The US system of progress is just fundamentally different than a more federal landscape that you see in a lot of other Western countries, especially European countries, where this is happening at the federal level. And so in some ways, I feel like Western Pennsylvania, the tri-state region, the city of Pittsburgh, we have a leadership opportunity. And in other ways, I feel like that just drives the competition down to the lowest common denominator between the domestic landscape. And I get a little bit nervous and opportunistic at the same time there. I have one more question, Bill. I can't see you. One more question? Okay, great. So rapid fire then from each of the panelists. What do you think the most important element we need to ensure the energy and industrial sectors can harness 4IR technologies and data to meet these net zero targets, to also drive economic growth, and to also advance global industrialization. So real small goals. I won't assign who goes first. Everyone has an answer at the ready.
Collaboration. Collaboration across, I mean, if you look at the panel here, we represent different aspects of what is necessary to make this happen. You know, if any one of the, you know, pieces of the stool or legs of the table falls off, it won't happen.
Allison?
Enabling policy, not disabling policy. So don't disincentivize a robust energy mix. Don't sacrifice security for the carbon trade-off. You can actually be carbon safe and energy safe.
Mark?
Money. At the end of the day, when people say it's not about money, it's about money. Everyone in the private sector that's in the industry is there's a for-profit business. How do we solve that then is how do you spend that money, right? And who's going to provide it? So the idea of a public-private partnership is actually, let's be honest, since Alexander Hamilton made the first public-private partnership, it's the federal government providing the money and the private sector then partnering with them to execute it because you need to be engaged in this, whether it's a university, whether it's a national lab, whether it's one of these manufacturing institutes we've stood up. That really winds up mattering. I think to be able to do that, and this gets to what we've been working on in the Department of Energy the past 6 months, is actually decoupling how we think about the funding we do in money from having one area focused exclusively on decarbonization and also how do you manufacture things for competitive advantage. Often those are spending things in an aligned area, but if we're going to accomplish this, we actually need to have two different offices, one focused on the decarbonization issue, the other one on the manufacturing competitiveness issue. And that's really what, you know, DOE's really been restructuring some of their efforts over the last 6 months.
I did not have Hamilton on my bingo card, so
Okay.
I used my free space for that. Marcelo?
I would say talent. I think that we have to not only work from the educational point of view, but also creating the right environments in our companies to be able to attract this talent and to help us accelerate the transition.
Chancellor?
Well, my colleagues have said all the good ones, so let me just add commitment. You know, we have a tendency to start off great and get all these things pulled together, and then we're having a different discussion 4 or 5 years later. To really make this happen, we need to have a sustained effort, and because this is going to unfold over a longer period of time if it's really going to drive the deep kind of transition that we want to see.
So as we think from a regional economic development perspective, that actually becomes a playbook for a place like Pittsburgh. Collaboration, enabling policy, money, talent, commitment. That's your takeaways, folks. Thank you very much. Thanks to all the panelists. It's been a really great conversation.
Thank you.
Thank you.